the Mona Lisa. And unfortunately, I tried this out with my browser because I wanted to do this presentation in my browser. And it's a hard problem to stipple an image. So I could only use 1,000 points, and then that this is an example which I didn't use, which isn't formed in the browser. And then you can obviously see that this isn't an optimal tour because there are crosses here. So that's a bit of a shame. And it's an indication that the traveling salesman problem is a hard problem to solve. But if you take this offline and invest more time, because I tried it with 10,000 points and it just freezes in my browser, so I took this offline, and this is actually an example of a rendition of the Mona Lisa solved as a traveling salesman problem and painted the tour. And I think this is a very nice example of how fundamental research in mathematics and computer science combined with art can form beautiful pictures.
So, let's see. So, all of my work really starts with some image. To show you what's going on, I generated a black and white image of a smiley face. And what I'm going to do next is turn this into an instance of the traveling salesman problem. And to do that, we just have to place down a whole bunch of dots. And it's essentially what artists call stipple drawing. And those dots, when you squint, look very much like the image that we started with. Regions that were dark received a lot of dots. Regions that were bright received considerably less dots. Regions that were completely white received no dots whatsoever. So I have a stipple drawing, a collection of dots. And now I'm going to view these dots as cities. Okay, we're flying up above, and these are cities down below. Alternately, this is a map. Okay, we have 2006 cities. I made this in 2006. Imagine that you're a salesperson who lives in one of these cities. You have to visit each of the other cities once and only once, and then return home. Okay, you're environmentally minded. You don't want to waste fuel. You don't want to waste your time. You don't want to spit out more fuel particles, pollution particles into the atmosphere than is needed. So you want to find the best route through these cities. You want to find the best tour. Okay? Mathematically, well, artistically, what I'm going to be doing is using the least amount of ink to connect all these dots. That's the traveling salesman problem. And when you do that, you end up with a picture that looks like this. Okay? The particular type of traveling salesman problem that you end up with is called a geometric traveling salesman problem, because the lengths of the edge segments, the line segments, are given by the Euclidean distance formula. And it's known that for Euclidean traveling salesman problems, if you look at an optimal solution, you're not going to find any edges crossing. That would be suboptimal. And what that implies is that this resulting object, this tour that the salesman follows, is a Jordan curve, a simple closed curve. It's topologically equivalent to a circle. It divides the plane into two regions, an inside and an outside. And that's something that I take advantage of in my art. I just want to show some of my pieces here. This is one that I did for a conference in Pittsburgh based on a portion of Sistine Chapel photograph. That, you have the hand of God, the hand of Adam.